Kavya? Yes. Okay. Then why you're not answering? Just answer. Can you see the slides?
Yes, Miss.
Yes. Okay. Answer your attendance. Afla,
Present, Miss.
Ajvina,
Present, Miss.
Amaya,
Present, Miss.
Atulya,
Present, Miss.
Drishya,
Present, Miss.
Jyotish, Karthik,
Present, Miss.
Kavya,
Present, Miss.
Nachiket,
Present, Miss.
Neeraj,
Miss.
Rangi, Vaishna,
Present, Miss.
Vaishnav,
Present, Miss.
Anjali, Anjali, and Shruti.
Present, Miss.
Jyotish is there? No. Okay. Let's start today's class. Last class, what we were discussing is about the routing table. What are the various fields in the routing table? I told if you are making use of classless addressing, minimum 4 columns are required in the routing table. That is the mask, network address, next hop address, and the interface. And also, I have told you about the autonomous systems. Now, what is autonomous system is, see, when you are considering an inter-network, a single protocol is not able to handle all the tasks, right? So what it has done is it has been divided it into autonomous system. Now autonomous system is nothing but you are having a collection of networks under the authority of single administration. And also I have told you, if you want to do routing inside the autonomous system, you can call it as intra-domain routing, also called it as internal routing. Okay, and if it is between the autonomous system, it is referred as inter-domain routing or external routing. Okay, so based on that, you can have two different protocols or algorithms in under intra-domain. That is called it as the distance vector and the link state algorithm. Now today you will be studying about the distance vector algorithm. Very, very important distance vector algorithm. Now what is this distance vector algorithm? Actually, this algorithm goes by the name Bellman-Ford algorithm. Bellman and Ford, they are the two inventors of this algorithm. So this algorithm is also called it as the Bellman-Ford algorithm. Now this algorithm earlier, originally, it was used in the first packet switch network. You can call it as the ARPANET. The first packet switch network is called it as ARPANET. So this algorithm was initially used in the ARPA network. Okay. Now later in internet, it was under the routing protocol. I have told you about the routing information protocol in the last class. So they made use of this algorithm. But nowadays it is not used much. Now you should know what is the working principle, how the algorithm works. All of you, please listen here. This algorithm is very, very important. Okay. Now, what is the protocol framework? Now, all of you listen. You are having a diagram on the right-hand side of the slide. There you can see different nodes like A, B, C, D, and E. Okay, now how the algorithm work is you have to find out the initial state of each node. What you have to do is you have to find out the initial state of the node. Initial state at the node means you have to find out what is the distance or cost to neighbors. Okay, see, if you are considering node A, you know who are the neighbors of A. B and C are the neighbors of A, and you are having the distance or the cost, you can tell. And from A to B, the distance or the cost is 1, and from A to C, the cost is equal to 5. Right? So initially, what is your first step is you have to find out who are the neighbors, what distance it covers from each node. Now, as the algorithm proceeds, you will be reaching the final state at a node. Final state at a node means you will be knowing the cost to all the nodes and also the next hop. Next hop is nothing but in order to reach the destination, maybe you might have to cross different routers. So that is called it as the next hop. So once the algorithm proceed, you will be finally reaching the final state, and there you will be knowing the cost to all the nodes. Okay, now whenever you want to implement a protocol, you have to handle 3 questions. One is what information to exchange, how to act on a message, and when to send the message. These are the 3 things that you have to understand. What information you have to exchange? What is the message format? Now, how to act on a message? How to act on a message means once a node is receiving a message, what action it has to do. That is the meaning of action. Understanding once a node is receiving a message, what action it has to do. Now, the third question is when to send the message. So these are the 3 things that you have to keep it in your mind when you are implementing a protocol, right? What information to exchange? What is the message format you have? Now, if a node is receiving a message, what action you have to undergo, and when you have to send that corresponding message, right? Now, what are the states maintained in the distance vector algorithm? The initial step, what you have to do is whenever you are having a problem or a sum given like this, the initial step, what you have to do is you have to maintain a routing table. Or you have to find out the distance vector in case of distance vector algorithm. Okay, now what does that routing table consist of? You can have the first field is nothing but it is the destination. Second field is the estimated cost. Understand? It is estimated cost to the destination. Estimated cost means for the time being, what is the cost? But as the algorithm proceeds, the estimated cost will become the final cost. Now, the third field is the next hop. The meaning is through which router it has to reach the network or which node it has to reach the destination. Right? So these are the things that are present in the routing table. Understand? You are having a network. First initial step in distance vector algorithm is you have to find out the routing table at each node. Now, as an example, you can see in the slide a routing table for node A is given. The initial routing table at node B, B is given for you. Now, if you are assuming this node B, who are the neighbors of B? You are having A as the neighbor, you are having C as the neighbor, and you are having E as the neighbor. The meaning is you have got a direct link to that nodes. So these are the destinations now. B can reach A, B can reach C, and B can reach E. They are the immediate neighbors. Right? Now, what is the cost of reaching from B to A? Now, it is specified that the cost is equal to 1. Now, the next hope is A itself. The meaning is you can, since it is directly, you can reach A, the next hop also remains the same. Since B can be reached directly through A, the next hop remains the same. So you are having A itself there. Okay, now considering C, the destination is C. Now, what is the cost from B to C? You are having 3 as the cost, and the next hop is through C itself because it is the direct link. Now, the other neighbor or the other node that is having a direct link to B is equal to E. Now, what is the cost of that link? It will be equal to 9. Since it is directly connected, the next hop also remains the same. So this is how you have to create your initial routing table. This is just an example I have told about for node B. When you are having a problem, when you are getting a problem, you have to find out the initial routing table of all the nodes. Okay, so assume now what are the contents in that routing table is you will have the destination, you will have the estimated cost to the destination, and finally the next hop, which is how you can reach the destination, which is the nearest path so that you can reach your destination. Okay, so assume B is the node that I'm considering. Then who are the neighbors of B are A, C, and E. You have to find out the cost. It is 1, 3, 9. So you have to make a routing table. Understood this much? What are the fields in a routing table? Yes or no? Yes. Okay.
Yes, miss.
Now once as the algorithm proceeds, you will be reaching the final routing table at B. I will be telling how you are reaching the final routing table. Now, here what topology I have given is very simple because you have got only 5 nodes here. Sometimes 4 nodes will be given, sometimes many number of nodes will be given. So when you are considering an inter-network, it is not 5 or it is not 3. It is more than that. Okay, so when the number of nodes are increasing, the calculation is a bit difficult. So what is required is you require an efficient algorithm to calculate the optimized path. Okay, so distance vector, the initial thing is you have to create the initial routing table at each nodes, right? Now, what is the next thing? You have to do it. Now, what is the second step you have to do is each node, they exchanges with all its neighbors the routing table information. Initially, they will be creating the routing table. As the next step, what they have to do is they have to share it to the immediate neighbors. Neighbors, not to all the nodes in the network, they are sharing the information only to the neighbors. Now, what information they are sharing? Only 2 fields they are sharing. One is the destination and the estimated cost to destination. When you are looking into this routing table, the first 2 fields, the next hop is not shared. Initially, what they are sharing is you are having the destination, you are having the cost. Only that 2 columns are shared to its neighbors, right? So that is the second step. So the next hop information is not shared. So when you are considering this example, what it is, B shares its information only to its neighbors. Now, who are the neighbors of B? Neighbors of B are A, C, and E, right? Now, they will be sharing only the first 2 columns of the routing table. Okay, now, once a node receives the information, the second step is called it as sharing. Okay, now once a node receives the information, what action it has to do? I have received a routing table from my neighbor. Then what action I have to do? And that is based on the Bellman-Ford equation. Okay, so the action is based on action at a router or a node is based on the Bellman-Ford equation. Now, what is that statement of Bellman-Ford equation? Now it is written it as dx of y is equal to minimum of c of x comma v plus dv of y. Now what is all these parameters? Now what is dx of y? Dx of y is the least cost path from node x to y. Assume your source node is x and your destination node is y. So dx of y is nothing but it is the least cost path from node x, that is the source node, to the destination node. Right? So you have to find out. Now, what is the equation for that? This is equal to minimum of c of x comma v plus dv of y. Now, what is that v actually? Now, you can see out in the right hand side. Your source node is x. You might be connected to many neighbors, and that v is nothing but the set of neighbors. Understanding? V is nothing but the set of neighbors where the source node X is connected. Okay, so what you have to, how you are finding the least cost path is you have to find out the cost of X going to neighbor. Maybe it may be 2 neighbors, 3 neighbors. So you have to find out the cost plus the cost of reaching your destination. And the minimum value of that should be taken, and that from that equation you will be able to find out the least cost path. Okay, so I'm telling the Bellman-Ford equation once again. So dx of y will be equal to minimum of the cost of x comma v plus dv of y. Now the left hand side, that is dx of y, is nothing but the least cost path from your source node to your destination node. Now, how you are finding is you have to find out the cost of source node to all its neighbors. You have to add up everything, and finally you have to add with the cost of reaching your destination. Now you have to take the minimum of that, and you will be getting the least cost path from your node X to Y. Okay, you will better understand when we will do a problem. Right? So understand that once a router is receiving the message, it has to perform some action, and that action is based on the Bellman-Ford equation. Right? Now, what now again? What is the in order in it little more in a deeper way? What action is received? It has to do is once it receives a message from neighbor V. What is the initial step? Is you have to update the cost. The cost, you can call it as the estimated cost to destination based on the above Bellman-Ford equation. Change the next hope accordingly. Now for each y is nothing but the destination in routing table of the received message. Now you can find out the cost of that by using the equation that is given. Dx of y will be equal to minimum of current estimate comma the cost of x comma v plus dv of y. That is the equation for finding the estimated cost. So dx of y, it is nothing but, so each time you are getting the information from each nodes and from its neighboring nodes. So each time you have to find out which is the least cost path. Now you making use of that equation, you will be able to find out. Now how you are finding it? You will be having the current estimate. With that, you have to add the cost of reaching X through various neighbors plus the final destination cost. Okay, so all these are summing up, and the minimum of that you will be considering, and that will be nothing but the final cost. Okay, so once the algorithm is proceeding, each time the iteration you have to do it, and finally the estimated cost becomes the final cost or the optimal cost. And this is happening when a series of message exchanges is taking place. Okay, so initially the cost is called it as the estimated cost, and once the algorithm is proceeding, that is each time when you apply the Bellman-Ford equations, you will be reaching, or the equation will be converging to its optimal cost. The means the routing table is stable now. It was unstable initially, and the routing table becomes stable once it reaches the final convergence. Okay, so this is the working principle of the distance vector routing algorithm. Now, just we will see an example based on this. Now, this is the same example I have taken. Hope you are listening, all of you. Yes or no? Yes. Okay. Now, assume an example. Understand it clearly because I will make you to do a problem in the next hour. So you have to thoroughly understand the concept. Now, this is just an example. I have taken 5 nodes here, A, B, C, D, and E. The various cost also is given. The links, the distance through from one node to another, it is given in the diagram. Okay, now what is the initial step in the distance vector algorithm is you have to maintain a routing table, right? Now what are the fields in the routing table? I told earlier you should have your destination, you should have your cost, and you should have your hope, next hope. Now in short, I am denoting it as D, C, and H. Okay, now I am going to write the routing table of node A. Assume this is your node A, and I have to write what are the fields in the routing table, right? Now, A, then all the neighbors, all the nodes I have to just consider. So I have just written my destination nodes as A, B, C, D, and E, right? I have just written it. Now listen, from I am at node A, I want to reach the node A. That is my destination. You look onto the first column, first row. Okay, I am at node A. I want to reach my node A as my destination. Now, what is the cost of that? Do you require any cost of that? Because I am at A itself. So the cost is equal to 0. So I have just written it as A0. Now the next hope, evolving it in the same this thing. So the next hope, I am just mentioning it as A itself. Right? Now, A to B. B is my destination now. Now, what is the cost from A to B? It is given it in the diagram as 1. So my cost is equal to 1. Since you have a direct link from A to B, the next hope will be B itself. Understanding? I'm writing the routing table for node A, right? Now, from A to C, I have to write it because C is my neighbor. I have just written it with a cost of 5. I can reach C with a cost of 5. Since it is a direct link, my next hope is also remains the same. Now, what about the destination D? Is there any direct link between A and D? No. Since you don't have a direct link, you can represent the cost as infinity. Okay, so the cost is denoted as infinity. Now, the other node E is also present in that network, but there is no direct link from A to E. So the cost is again infinity. Understanding how you have to write the routing table for each node. Yes or no? Yes. Okay.
Yes.
Yes. Okay. So this I have done it for node A. Similarly, you have to find it for node B, node C, node D, and node E. Right? Now, coming to node B. Now, who are the nodes in the network? This is A, B, C, D, and E. Again, I have written. Now, I am at node B. I can reach my destination A with a cost of 1. So I have just written it. Since you have a direct link, the next hope is A itself. I am at B. I want to reach B itself with a cost of 0. Right? Now, I am at B. I want to reach C with a cost of 3. Right? C3C that I have written it. I don't have a direct link to D and D. So there is infinity. Now from B to E, the cost is equal to 9. Through E, since it is a direct link, the next hop is also remains the same. Okay, so this I have written for node B. Now, what for node C? Now consider the node C. The neighbors, I mean the nodes in the networks are A, B, C, D, E. Now, if I want to reach A, I have to make a cost of 5 through next hop router is A itself. Now, if I want to reach B, you have a direct link with a cost of 3, right? Now, if I want to reach C itself, the cost is equal to 0. If I want to reach D, the cost is equal to 4. And if there is no direct link to E, so it is remaining infinity. Right? Now, for node D. D, A, you don't have any direct link, so it is infinity. B, you don't have any direct link, it is infinity. C, the cost is equal to 4. D itself, the cost is equal to 0. And for E, the cost is equal to 2. And similarly, for node E, it can't reach, so it is infinity. B, cost is 9. C, it is infinity. D, it is 2. And for E, there is no, since it is the same destination, it is 0 E. Right? So this is the first step what you have to do in your distance vector routing algorithm. For each node, you have to find out the initial routing table. Okay, understood everybody how you have to write the initial routing table of each node? Yes or no?
Yes.
Yes,
Yes?
miss.
Yes or no? Somebody has told no. Who has told no?
Yes, miss.
Who has told? See, since you don't, if you have a direct link, you just write the cost as it is from the diagram. If you don't have a direct link, you mark it as infinity. That is the thing what I have done up to here in the initial routing table. Okay. Now, what is the next step? Next step is, I have told the second step is sharing of information. Now, assume you are considering only the node C. Now, my reference node is C. When you are getting a problem, you have to do it for all the routers. Now, for understanding purpose, I am just defining only one node here. Okay, so considering reference node C, I have just considered my node C. Now I know what is the initial routing table of C. That's what I have formed in the earlier step. I have just written it, the whole thing, the initial routing table. Now, what is the second step in distance vector is each node shares information with all its neighbors. Each node shares information with all its neighbors. So, since I have assumed C as my reference node, who are my neighbors now? My neighbors are A, B, and D. Okay, so router C, they receives distance vectors from neighbors A, B, and D. Only from its neighbors, not from any other nodes. You just assume you are getting the information or the distance vectors from your neighbors. So if I am considering router C, I am receiving the distance vectors from my neighbors A, B, and D. Now, once I receive that distance vector, I have to perform some action. And that action, I have told you, it is based on the Bellman-Ford equation. Now, what action I have to do it? So you have the initial routing table of C because C is my reference node, right? Now, who are my neighbors? My neighbors are A, B, and D. Now, what information I will get from those neighbors? I have told you they will share only the first two columns of their routing table. The meaning is A. From A, you will be getting the message as the first two columns. See, initially this is the step. See, A, the first two columns is this much, what I am highlighting. A0, B1, C5, D infinity, and E infinity. Similarly, the next neighbor is B. So I'm getting the first two columns of the routing table. Okay, so that is the thing. So Message from A, what I'm getting is the first two columns. Message from B, the first two columns of the routing table. Message from D, I'm just getting the first two columns of the routing table. Now, I know the cost of C to A will be equal to 5. That is understood, right? So, initial routing table is nothing but the current estimate. Now, what I know is I know the cost to A, right? I know the cost to A is equal to 5. Now, what I will do is I will add this 5 to all the information and compare with the current estimate, right? So if I'm getting some value, I will be just seeing which is the best value, which is the minimum value. I will be considering that path. Similarly, you will be getting from message from B. C to B, you know, the fixed, cost is equal to 3. And from D, C to D, the cost is equal to 4. So each time this cost, it is getting added to that the other cost. Okay, so I will just tell how it is being done. Okay, now what are the things that you have to find out is the cost of reaching destination A from router C, the cost of reaching destination B from router C, the cost of reaching destination D from router C, and cost of reaching destination E from router C. Why I have router C? Because C is my reference node. I want to find out the cost of reaching each destination from the router C. But I am getting the information only from my neighbors A, B, and D. So these four steps are the final thing. You are required to find out the cost of reaching destination A from your router C, that is C to A, cost of reaching destination B from your router C, cost of reaching destination D from router C, and also cost of reaching E from your router C. Okay, now, how will you find out the cost of reaching destination A from router C? That is the first step, what I am doing it. So I will, this here only one step is shown. You have to find out for the remaining things. Now, explanation for destination A, how I can find it. Now, router C can reach destination router A via its neighbors A, B, and D. See, C has received information from three neighbors now, A, B, and D. Now, what I require is I want to find out the cost of reaching destination A from my router C. Okay, so which is my destination now? This is A is my destination. But I have received messages from A, B, and D. So what I have to do is I have to find out whether I can go through the neighbors also. My neighbors are A, B, and D. So C can reach the destination router A through its neighbors A, B, and D. It will find out, and which path will give you the minimum cost, it will consider that. Right? Now, as an example, first what you have to do, cost of reaching router A from router C through neighbor A. I am going to find it out. Cost of reaching router A, the diagram should be in your mind. You are having the router A here. You want to reach it from C through neighbor A, right? Now, how you are able to find out is you have to find out what is the cost from C to A plus cost from C to C itself. So I know what is the cost from C to A. What is the cost from C to A? As per the previous diagram, message from A, what I'm getting, it is the cost to A, it is equal to 5. So that 5 I have just written. Now what is the cost from C to C? This will be equal to 0. So 5 plus 0 will be equal to 5. Okay, now the cost of reaching router A from router C via neighbor B. Through B, how can I reach my destination A? So how will I find out? I have to find out what is the cost from C to B, right? Plus, what is the cost from B to A, right? My destination node is A. I want to reach from router C. So the possibilities are from C to B and from B to A. I know what is the cost from C to B. Now, what is the cost from C to B? It is given it as 3 here. So that 3 will be added. Now B to A, it is equal to 1. So 3 plus 1 will be equal to 4. Right? Now, the third step, cost of reaching router A from router C neighbor D. I have to find out via neighbor D whether I can reach router A. So how I have to frame the equation is cost from C to D plus D to A. Cost from C to D, it is given it as 4. But cost from D to A, you don't have a link, so it is infinity. Okay, so I have to find out now which is the minimum cost. I have to got the values 5, 4 and infinity. Which is the minimum value? Minimum value is equal to 4. I am getting it. So the cost is minimum. Through which neighbor I have got the cost as minimum? Through the neighbor B. So router chooses that path. So what it will do is it will be creating an entry 4, B for destination A in its new routing table. Okay, so this is done. See, I have just told only for router C, and that too you have found out what is the cost of reaching destination A from router C. Okay, now this is the expanded step. Easily you can calculate from the topmost table. Okay, so this is the expanded way how you are getting the least cost. So minimum value, you will Bellman-Ford, how you are applying is through this. So you will be finding which is the minimum cost, and through that minimum, you will be reaching you will be finding the path. Okay, so similarly, you have to do it for the next step, cost of reaching destination B from router C. Cost of reaching destination D from router C. What are the possibilities? Cost of reaching destination E from router C. All these things you have to find out, and you have to make a table. Okay, once you make the table, you see whether it is converging. If it is not converging, you have to share it again. So this is the process of distance vector algorithm. Okay, so now it is 9:20. You can go for the break. 5th hour, I'll be just continuing with this. All of you take a paper, pen, everything. You are going to do a problem there. Okay, so hope somewhat it is clear for you. When we'll work it out a problem, you will better understand that. Okay, thank you. Absent is only, I think, Jyotish and Anjali is there.
Yes, miss.
Okay, Jyotish is absent, I feel. Right? Okay. Thank you. We will meet in the 5th hour.
Thank you.